Hello, viewers. Welcome to my channel. In this episode, we want to treat arithmetic progression, otherwise known as linear sequence, as the continuation of the sequence and series topic we started this year. If you are new, consider subscribing to the channel, like, and share. So, under arithmetic progression, we are saying that the definition of the term can be in two forms. As in one, an arithmetic progression is a sequence where each term except the first term is obtained by adding a fixed number to each previous term. So if I have the terms to be 1, let's say these are the terms. We explained that each of the elements in a sequence is called a term. So there are 1, 2, 3, 4, 5. There are 5 terms here. First term, second term, third, fourth, 5. Okay. Now, we are saying that except the first term, each of the terms that you get will be addition of a fixed number to the first term or to the previous term. So if I want to get a second term, I need to look at what number is being added to the first term to give me this. If that number is 2, it means that 2 is the fixed term, the term to be fixed. Whatever I add to a term to get the next one should be constant. So 2 plus 1, 3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. So this is a finite word example of a sequence. Alright. Or the definition could also be an arithmetic progression is a sequence where the difference between every two consecutive terms, are the same. What are the consecutive terms here? So the difference between these two terms are consecutive, meaning they are following each other. The difference is going to be 2. If I take these 2, the difference will be 2. This will also be 2, and final 2 will also be what? 2. You can see the differences between them. 2. That's the common difference. So the word is the difference between the two terms. So now let's see. You can see that from this definition, the two definition, we can deduce some terms from here as what? First term. So we can take a first term. We can also take a term from here as what? Difference, which we can term as what? Common difference. The first term is always referred or denoted with A. Then the common difference is also denoted with what? D. So in this we have first term, we have a common difference. Now, if I want to find the number of terms, in this sequence we have only 5 terms because it is finite. It could also be infinite set, whereby there are other series of terms which are unknown. So I can be asked to find the 15th term, to find the 20th term, or even the 100th term. So it means this, we can also have what they call the nth term, which in some books we use the UN to indicate. Sometimes we also use A subscript N or T subscript N. So these are used to deduce the terms as nth term. So if this is 1, it means the first term. If this N is 2, it means the second term. So third term in that order. Alright. Now, since we explained also under sequence and series that series is just the summation of all the terms in that sequence, we can also have addition of all of this called the sum of the nth term. Which is also denoted using what? The Sn. So these are the 4 terms. When I mean terms as words. 4 terms that we are going to consider when it comes to the AP or linear sequence. let's see how we can explain it in terms of progression. How we can deduce that formula that we can easily use to solve these kind of questions. So let's see. We already know the first term of this sequence could be what? A. If I want to find the second term, we are saying that we add the common what? Difference to the first term. So the first term plus the common difference, which we are using what? D to indicate that. Don't forget, first term is 1. So 1 plus common difference, which is 2, will give us 3. Then if I am looking for the third term, that is also going to be the term here, which is the previous term plus what? The common difference. We are no more going back to this. That will be A plus D, which is the previous term, plus the common difference D. And D plus D will give us what? 2D. So that becomes A plus what? 2D. And in the same way, if I am looking for the fourth term, will be the common difference plus the third term. What is my third term? A plus 2D plus the common difference, and this will give me A plus what? 3D. You can see we can continue in that order. So you can see first term, second term, third term, fourth term. Let's arrange them in that order. We are saying that U1 will be first term if n is 1. So my first term is going to be A. My second term will be U2, which will be A plus what? D. Then the third term will also be A plus 2D. Then let's go to the fourth term as what? A plus 3D. You can see that the first term keep on repeating. The second term, which is the D, keep on what? Increasing with coefficient. There's a coefficient of 1, of 2, of 3. That also means that here there's a coefficient of 0. So I can have plus 0D, which does not change anything. But I can see, let me look at the difference between the terms. First term, coefficient of D, 1, 0, 2, 1, 3, 2, 4, 3. Can you see the pattern? That as this is increasing, we are also having this increasing, but the difference between them keep on being 1. 1 and 0, difference of 1. 2 and 1, difference of 1. 3 and 2, difference of 1. 4 and what? 3, difference of what? 1. So if we are saying that UN stands for the nth term, we know I want to find the 15th term, so I'll represent this n. So you can see that this is going to be n. The A is the same in all of them, so I put my A there. Now, what is the relationship between the n and the number in front of D? You know, the D will come. You can see that for me to be able to get this, I have to find the difference of 1. Either I add 1 to whatever is here to give me this, or I subtract 1 from this. 4 minus 1, 3. 3 minus 1, 2. 2 minus 1, 1. 1 minus 1, 0. So it means that I need to subtract 1 from the n before I multiply by the common difference. So that simply means that if you are looking for the nth term of any AP or a linear sequence, it is going to be given by this formula, where A stands for the first term, N stands for the number of terms, the D for the common difference. So if you are using T, it will be the same thing. If I'm using the subscript A, so this is the formula that is being used to find the nth term, number of terms in a sequence. So we made use of the first term, common difference, and this. This is the sum, which we will deal with that in subsequent episode extensively. So now let's see. using this to solve an example. Find the 12th term of a sequence 19, 14, 9, and 4 continues. This is an infinite word example of a sequence. So first thing first, you have to find out whether is this AP or GP. If it is AP, there should be a common term that is being between the two consecutive terms. So if I take the first two terms, 19, 14, the difference between them is 5. If I take 9 and 14, the difference of 5. 9 and 4, difference of 5. So it's a common terms of 5. But it is always the previous term, the next term minus the previous term. As in, if I want to find the common difference, we know if it is first term, second term, this is what you're looking for. It is this minus this. As in, A plus D is the second term minus the first term. So A minus A give us 0. I'll be left with D. But A plus D is U2 minus A, which is what? U1. That gives us what? D. So it's always the second term minus first term, third term minus second term, fourth term minus third term in that order. So let's see what the common difference will be. Our first term is going to be 14, 19. The common difference is going to be the second term minus the first term, which is going to be 14 minus what? 19. That gives us negative 5. Even though the constant number we have as common difference, the constant number is 5, but the common difference will be negative 5. So if you are looking for the n, so that will be 12 term. So in all, U12 is going to be A plus n minus 1 times D, where the n is the 12. So we change this with 12. So that become A, which is what? 19 plus 11 multiplying D, which is negative 5. 19 will come. We have negative what? 55. So if we perform the subtraction, I think we have negative 36. So it means that if we want to continue subtracting 5 from the term in order to get the next one, before we get to the 12th position, we will end up having what? Negative 36. Alright, so this is just the introduction to the AP. In the subsequent videos, we will take more examples, how to find the nth terms, how to find the last term, how to find any of the terms before we move on to the sum of the n terms. Thank you so much for watching. If you like this video, don't forget to share with your friends, like and subscribe. Bye bye.